Hello, and welcome to Based Mathematics. My name is Snacks, the Druid, and today we're going to be talking about binary and Leibniz. Now, if you don't know what binary is, it is a number system, positional in notation, but following 1 and 0. It's also pretty much the entire reason any computer or robotics piece functions, because there's an on state and an off state, basically. You got on and you got off. But in this video, I kind of want to teach people how to count in binary, or how to look at binary, how, the numbers work out, how it functions, I guess. And then I want to get into history of Leibniz, the founder and developer of what we know as binary, and his motivations, because of all the mathematicians that I look up to and idolize, it's this man right here. I think he's real cool. I think he's a swell guy. G Money is what I call him. And his peers and family, they all called him G Money too back in the 17th century, I think. Yeah, it was like 1600s and 1700s. But basically, if you don't know what binary is, it is a base 2 system, meaning that it only has 2 values associated with it, or 2 digits. It's got 1 and it's got 0. 1s are odds, basically, and 0s are evens, kind of, I think. But what you get is you get a positional system, and it goes 2 to the power of 0, 2, 1, 2, 2, 2, 3, 2, 4, 5, and quite frankly, as far as you want to go. The world really is your oysters when you're dealing with binary. But to make this a bit simpler, 1, 2, 4, 8, 16, 32. And all you do if you want to count in binary is you add up whatever multiple of 2, or exponential value 2. So let's say you've got a number like that. I don't know the number right off the gate. But all you do is you go, all right, cool. Is 1 a part of it? No. Is 2 a part of it? Yeah. Is 4 a part of it? Yeah. Is 8 a part of it? No. 16 a part of it? Yeah. 32 a part of it? Yeah. And then you add these up, and you get 20 to 54. And that's pretty much how you count in binary. If this were completely made up of 1s, it would be 63. And one of the interesting things about this, and if you watched my prime distribution video on how the primes get distributed across the number line, it shows a deep interconnectedness between the number digit values of 2 and 5. And I think binary is the reason, because if you take yeah, that's professional. You take something like this, where you have 1,000. We know that's 8 because it's right there. But this is 2 to the power of 3. And if you go in decimal and you go 5 to the power of 3, you get so it's an interconnectedness between 5 and 2 is the real crux, I think, because the equivalent exponential power of 5 and the multiplied by the equivalent exponential value of 2 makes whatever the binary position is. It's interesting. If you didn't know, now you know. But another interesting thing about binary as a whole, at least maybe not a whole, but let's look at Mersenne primes real quick, or at least perfect numbers, the perfect number formation of the binary formation of perfect numbers. Sorry, I ramble. I like rambling. I'm a rambling man. Rambling and gambling, which I count cards, so I turned $200 into $450 at the casino. But you have perfect numbers. So what we have: 6, 28, 496, 8,128. And so the way that you get these is following the Mersenne prime formation. So Mersenne prime is any prime that when you take 2p minus 1, that number is prime. Similarly, I think it was, might have been Euclid. It was some Greek dude who was cool. I just can't remember his name off the top of my head, but I think it was Euclid. Proved that if a prime is generated in this form, you get a perfect number. That is 2p minus 1 multiplied by 2p minus 1. And so, for instance, if you were to take p equals 2, so you get p equals 2. So you go 2 minus 1 is 2, 2 minus 1 is 1. 2 times 4 minus 1 is 3, so you get 6. I think it's 3. 496 is that 31? I can't remember. I can't remember these ones off the top of my head. But anyhow, what you get is you get a binary formation that is for 28, 1, 2, 3, 1, 2. And so you have what? You've got 0, 0, 4, 8, 16. 16 plus 8 is 24, plus 4 equals 28. So with the binary formation of any perfect number, you get whatever, you get p1s and you get p minus 1 zeros is the equivalent exchange for the binary of perfect numbers. I think that this disproves the notion of any odd perfect numbers in the very, very large, high probability categories, because that's kind of, there's a very specific binary coordination for perfect numbers. I don't care what that Harvard dude says. But anyhow, now let's talk about Leibniz. Gottfried Wilhelm Leibniz, G Money, as I like to call him. G Money, Gottfried Leibniz, was not always a mathematician. In fact, he reached his understanding of math and what he liked to do later on, I think around the age of like 26, 27-ish. But at 20 years old, he, I believe, was graduated as a philosopher and a lawyer, or at least he went to college for philosophy and law. And then upon going to, I think France, I don't know, I think it was Paris, he met with Christian Huygens, Huygens, who started talking about like numbers, philosophy, whatever they were talking about, because they didn't have computers at the time. And was basically like, hey, have you heard about this stuff that like Rene Descartes was doing, or the other ones? Descartes was the big math name of his day. And so for 2 years, Leibniz became pretty much a master of like algebra, trigonometry, or geometry, just about every mathematical discipline of his time, and then developed his own formation of calculus, completely independent of Newton. And the reason Leibniz is better is because he wasn't a shut-in virgin with mommy issues like some of the other people who discovered calculus. He's also the one who revolutionized d over x, or dx dy. Like I've said, I don't have a calculus background. I kind of didn't care about math. I'm more of a philosophy guy and just thinking about things, looking at things. It's not that I wouldn't like to learn calculus, it's just don't have the time. I'm waiting patiently for a calculus teacher like Aang waiting patiently for an earthbending teacher. Eventually it'll happen. It's called having neutral Jing, or I think that was the Avatar: The Last Airbender thing. But he also, whatever that is, integrals. I think he was the integral calculus guy. And so most people actually prefer Leibniz's form of calculus over Newton's. And the difference is Newton went to school to be a math guy. Leibniz went to school because of spiritual philosophy and law, and then got interested later on. But his reasoning for developing binary is because of the dual nature of God. Because like everybody just about in that time, they were very deeply Christian-centered and organized all their thoughts that way. And what Leibniz thought is that God, in his mighty powerfulness of everything, divined and created everything in the universe as just in order of numbers. Just little teeny bits and pieces. And if you want some good reading, go check out his monadology. I think that's actually how he spelled it. I'm American English, so it's like a Y, but he wrote it in France, I believe, like while he was on his deathbed for the most part. And basically in his monadology, it was about these things called monads that were the indivisible, infinite aspects of reality that God put everywhere, and they hold everything together, which is cool. But he developed binary because of the dual nature of God. What does that mean? So you have on, off, yes, no, growth, decay, existence, non-existence, life, and death. See, he views things as there's no in between, really. You either have or you have not. You do or you don't. You can or you cannot. You know, those two things. I like to think of the reason binary really works is because all math pretty much stems from a circle, I think. And so now you cut the circle and you have one half and you have the other half, and this half is not that half and that half is not that half. And I genuinely think that's where all math formulas and formations, number nonsense comes from, is that right there, that little guy. But one of his big inspirations for it is something called the I Ching, which is one of the oldest books of wisdom in Chinese culture. See, the I Ching started off as tossing bones, if you've ever heard of that form of divination. It's divination. It's a divination method. But the I Ching is basically you have 8 trigrams made up of 2 lines. So you have that or you have that. And this is what he thought the binary aspect was, is that you have, I think it's yin and yang. Yang is broken, yin is full. And from that, you stack them in 3 because they're trigrams. And so you can have that, 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 and that. So you have 8 of these little formations, and the way that you do this, if you're interested in the I Ching, is basically, for modern interpretations, is you can take 3 coins. Some people say that they have to be all the same. It doesn't matter, it's 3 coins. You're going for an on or an off, right? And so you take those 3 coins, you shake them up, and you ponder a question. You think deeply about your position in life, where you're at, where you're wanting to go, what you're wanting to do with the world at this given point, and where you're wanting that trajectory to go. You ponder, you write down your question, you write it very in-depth. You don't want a yes or no answer, you want a complex question, because you want a complex answer. And you shake it up, 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 you ponder, you ponder, you ponder, you shake it up, you shake it up, and then you toss the coins out into a receptacle anywhere, and then you record whether it's heads or tails, all of the coins. And so if you have 1 or 2 heads, the line is full. If you have 1 or 2 tails, the line is broken. And if you have 3 heads, you have a full line and a circle. You mark it, it's changed. And then if you have 3 tails, you have broken, and you have an X through the center. And basically what that does is you order it, you start out at the bottom, you draw the first line, then the second line, then the third line, fourth line, fifth line, sixth line, and it gives you 1 of 64 potential readings on it. And then whether or not you have marked lines gives you an extra little bit of information about, you know, where you're going, whether you should hold your course, whether you should turn and walk away. Because, and here's the thing about divination. So we're gonna sidetrack real quick, as if I haven't been sidetracking this entire time, because I am a scattered brain, which is fun. Divination. A lot of people think that divination is telling you the future. No, it is not. Divination is reading the present so that you can figure out your trajectory for the future. That's why it's so prevalent in like Jungian psychology. And so what you're doing is you're asking your question about your present, where you want to go, what you want to do. It's not telling you the future per se, it's telling you where the trajectory is heading from this present point. Because you can always shift your course as you learn new things and go forward. I'm a big believer that there is a central plan or unavoidable reality consequences that we humans are forced to face at some point in our life. And they're unavoidable. You know, it's just something that we maybe signed up for in a reality realm, dimension, whatever you want to call, of our soul state. But the divination method is for tracking your trajectory. Man, I'm just like scatterbrained. It's hot in here. It's really hot in here. But the way Leibniz's binary was received by his peers was akin to if a 5-year-old were to show you a frog, or show just anyone a frog, and they'd look at the frog and be like, "Wow, cool. Okay. What's the point? What are you trying to do?" And the 5-year-old's really just stoked on this frog. They're like, "It's cool. It's a frog, man. It's a little froggy guy." And the adult is like, "Yeah, but like, what's the point? Who cares? You know, what? It's a frog." And if you're one of those people who doesn't think a frog is cool, if a kid shows it to you, you're not my kind of people. Sorry, I think frogs are cool. But yeah, it was very unceremoniously received, I guess is the term, because everyone was so focused and hyped up on calculus at this point that something like binary just didn't seem to have any point, any structure, any real applications until, you know, the 1930s to 1940s, when we started developing computers and technology, and they looked at this really outdated, weird form of mathematics that this dude, this hyper genius, discovered. They were like, maybe I don't know, maybe if we did this and we plotted some things, maybe it would work with machines. And lo and behold, it did. And now we have phones. Now I can record myself having a nervous breakdown on a blackboard for you people who are watching and maybe want to learn a little bit about history or numbers. And now, Leibniz's inspiration for the binary system had to do with math, because numbers are math. But it was so much more because he was after the divine cause, is what I'd like to call it. The why, the how, the because of the reality that we exist in. Because he was a philosophy guy. Leibniz is one of the greatest philosophers in the world. And the monadology he wrote like on his deathbed, basically. It was I believe his last work that he did. And it always makes me wonder, though, why certain people produce their most spiritually entrenched works right on the verge of death. Is it because of the fear of death? The questioning of the unknown that comes from the void of non-existence? Or is there something more to it? Because, upon Newton's deathbed is when he started doing more research on the Christian numerology, the numbers associated with it, the days, the book of Revelation specifically. And you want to know when, because Newton was smart, he had daddy issues, whatever. Who doesn't? Who doesn't? But he was a Christian. He didn't believe in, I don't think he believed that Jesus was the literal interpretation of God, which I don't either. Because he was just a product of that. He very, believed in the Bible. But the book of Revelations talks of Armageddon, talks of, the world ending as we know it. It's going to just corrupt. But what Newton did was he took the planets and kind of ran them back and figured out did a full chronology of the ancient kingdoms of the world and the planetary positionings that they had noted, and actually realized that our years were off. And that's why around that point, they go backwards 11 days, I think. Because of Newton's works, I believe. Maybe it was someone else, but I think it was Newton's, because there's like an 11-day backtrack at a certain point. But Newton predicted that the end of the world was going to be in 2060, which is well within our lifetime. Newton. I just like writing on Blackboard, if I'm being honest. That's really what my channel is. I like writing on Blackboard. I don't know if people have got anything out of this. I don't know. I'm kind of just like rambling. But yeah, Leibniz and binary. His nature of God. The truth that he was seeking. Because at the heart of any scientist, any mathematician, any philosopher is a deep, entrenched desire to find the truth, to uncover the unknown, to delve deeper into the mysteries of the world. And Leibniz creating binary was just his example of revealing some of those hidden natures of the world. I think that's about where I wanted to go. I think I gave a good how to count in binary. It's pretty simple. You just have to know the exponential powers of 2 and then add up the positional notation. It's pretty simple. Yeah. Anyhow, please like and subscribe if you're interested in me as a personality, or you want to learn more about number bases and my kind of weird roundabout method. Binary is not my favorite base, but it's definitely useful. It's definitely a good stepping stone, and it's kind of where all math really starts from if you want to go into positional and number notation. So thanks for watching. Please like and subscribe, comment if you'd like, be polite. Probably. Anyway, thank you.